We see the moon all the time, but most people don't realize how important it actually is. Not just our moon, but moons across the solar system. So in this video, I'm going to walk you through the full story. Why ours is so weird, how it formed, why we're going back, why we're planning to build a moon base, and why other moons might be even more important than ours. So let's start with something strange, our own moon, because it is not normal. Mercury and Venus have no moons. Mars has 2, but they could easily pass as space potatoes. The gas giants have a whopping 400 known moons. And Earth, well, we've just got 1. And somehow it's kind of perfect. In today's video, we look at Earth's moon and why it's so incredibly special. Because once you look closely at the moon, you see that it's not normal. So about 1/4 of the moons in the solar system are small, lumpy, and not very moon-like. The rest are honestly pretty interesting. In my opinion, way more interesting than the planets. But Earth's moon is probably the best for a couple of reasons. Number 1, it is huge. Now, it's not the largest moon in the solar system. That title goes to Ganymede, one of Jupiter's moons, but compared to its planet, it's gigantic. If the Earth were the size of a basketball, the moon would be roughly the size of a softball. But if Jupiter were the size of a basketball, its moons would be no bigger than grains of sand. Phoebe! And the moon doesn't just exist, it does things. Really, really important things. Like first, it gives us tides. The moon's gravity pulls on Earth and the Earth's oceans, causing them to bulge, which mixes nutrients and water, and it shapes coastlines. And it's probably the reason why life first left the oceans and went onto land. I've got a whole video on tides if you want to check that one out. Second, the moon gives us stability. Now, the Earth tilts on an axis at about 23.5 degrees, and that's what gives us seasons. And without the moon, that tilt would wobble wildly over time. Seasons would go from extreme to extreme, and it would be nearly impossible for life to survive in those kinds of conditions. I've got a video on seasons too. And then there's this, total solar eclipses. Now, while the moon is 400 times smaller than the sun, it's also 400 times closer to Earth. And as a result, the sun and the moon appear almost exactly the same size in the sky. That is an astonishing coincidence, and no other planets have anything like that. And for a brief moment, the universe aligns, daytime turns to darkness, and the sun's atmosphere glows around the silhouetted moon. It's beautiful, it's rare, and it only happens here. And here's the big question. If moons are so plentiful and so useful in our solar system, why does Earth just have 1? And the answer lies in where our moon came from. Well, for many years, scientists had 3 main ideas that they thought might be the reason why we have a moon. First was the capture hypothesis, that the moon was just flying by and Earth's gravity sort of grabbed it and got it to go into orbit. And that does happen in our solar system. Usually those captured moons have really weird orbits, and our moon's orbit is perfectly normal. It's almost like a circle, and our gravity isn't nearly strong enough. That would be like a baby on the side of a bowling alley trying to catch the bowling balls that passed by being thrown by Jason Momoa. Second, there was the co-accretion hypothesis, that maybe the moon and the Earth both formed at the same time out of the same bunch of gas and dust that was in the early solar system. But if that were true, they'd be more similar in size, and they'd have the same amount of iron in their cores, which is quite different. And third was the fission hypothesis, that the early Earth was spinning so fast when it was all molten that it just kind of shot the moon off in globs, like a tire full of mud on a bike. And that's a fun idea, but for that to happen, the Earth would have had to have been spinning so fast that it probably still wouldn't exist. Now, each of these ideas sounded pretty good until science and mathematics proved them wrong. So where did the moon come from then? And the answer came from a most unexpected place. Actually, it was quite expected. It was from the moon itself. Astronauts in the late 60s and early 70s of the Apollo missions brought back over 800 pounds of moon rocks to Earth to be studied by scientists. And those rocks told scientists something that made them rethink everything. And that's what we'll cover on our next episode. We'll talk about where the moon actually came from. Everyone knows that the moon is fantastic, but what we didn't know for a very long time is where did it come from? We had some great ideas, like maybe the Earth's gravity caught the moon, or maybe the Earth and the moon formed side by side in the early solar system, or maybe the Earth was spinning so fast that the moon just flew off of it. All reasonable ideas, but it seemed that the only way to tell where the moon really came from was to actually go there and find out. So in 1969, when Apollo astronauts landed back on Earth, they brought some moon rocks with them. And scientists were seriously geeking out at the idea of studying those rocks. And I get it, as a fellow geology nerd, the stories that those rocks could tell are unbelievable. And one thing that really caught their attention was a lonely little isotope called oxygen-17. Think of isotopes like atomic fingerprints, or very unique versions of an atom. You see, inside of Earth's rocks, there's a very specific amount of oxygen-17, and asteroids have a different amount than us. Mars even has a different amount. So the moon's oxygen-17 fingerprint should look different, but it doesn't. Moon rocks and Earth rocks have almost identical fingerprints, and that meant something huge. Whatever made the moon, it wasn't something Earth grabbed, it wasn't something that formed gently nearby. It had to involve Earth itself. So after plugging the data in, modeling it on computers, using geology and tons of science, a new and bold idea was proposed: the giant impact hypothesis. Early Earth was hit by a Mars-sized object, an out-of-control planet called Theia, and the impact was so violent that rock melted, material vaporized, and debris blasted into orbit around Earth. But that debris didn't escape into space, and over time it formed into a new Earth and the moon. And this idea explained a lot, like why the moon is so large, why it has so little iron in its core, and why the Earth spins the way it does. And for a while, it felt like the mystery had been solved. But there was still a problem. If most of the moon came from Theia, why does it look chemically identical to Earth? So scientists had to ask, did we miss something? And instead of throwing out the giant impact idea, they merely upgraded it. Because scientists are still studying these rocks, and with better information and stronger tech and computers, we can understand things much better. We're not being flaky, we're just being honest in our best understanding of the universe and how it works. And now the explanation of the moon's formation got a little bit more destructive. The collision that formed the moon was so violent that Earth and Theia were thoroughly blended, their materials completely mixed, kind of like a cantaloupe and a watermelon smashing into each other, breaking into a million pieces and coming back together as a waterlope or a cantermelon. Now, do we know exactly what happened? Well, absolutely not. We weren't there. That was 4 billion years ago. But I'd bet the scientists are pretty stinking close. And now we know that the Earth and the moon are kind of like Danny DeVito and Arnold Schwarzenegger in the movie Twins. They both come from the same basic DNA, but they're very different. And this isn't just ancient history, because the moon is basically a time capsule. No erosion, no plate tectonics, and no weather to change the surface. It's pretty much the same now as it was a billion years ago. And if we want to understand how planets and moons form, the moon still holds answers, which begs the question, why haven't we been there in 50 years? And why are we suddenly going back now? And that's what we'll answer in episode 3. In 1961, President Kennedy gave a speech saying he wanted to send people to the moon. Can you believe that? 1961. This was a brand new car in 1961, and this was a computer. No, not the machine, the person. They were literally called computers at NASA. But despite this primitive technology, we actually did it. An amazing feat. And now we're going back. But I have to ask, why did we go in the first place? In less than 10 years, humans went from Earth to another world. 6 missions landed on the moon, 12 people walked on its surface. They brought back hundreds of kilograms of rock, clues to how the planets form and how Earth itself began. They even left instruments that still send data today, measured the moon drifting away from the Earth, and learned how to survive far from home. And the strangest part? The only movie that I ever saw about these missions was about the mission that didn't make it to the moon, Apollo 13. But Apollo proved something bigger than technology. That curiosity, teamwork, and a willingness to take risks can change what's possible. And then, after all of that success, we stopped going to the moon completely for 50 years. Huh? So after Apollo, it wasn't that the moon stopped being interesting, it's just that space is expensive. The Apollo missions cost about $300 billion in today's money. I mean, do you think that's worth it? And it was risky sending humans to the moon. It's very dangerous doing that. And once the Cold War cooled off, there wasn't the same political pressure to get people up there. Because let's face it, a big reason that we went to the moon was simply to beat the Russians. Now robots are cheaper, satellites are safer, and we have plenty of things to fix on our own planet. So we left, mission complete. We did everything we needed to do, right? So if we already went to the moon in the 1960s and 70s, why are we going back now? Well, this time it's not about planting a flag, it's about learning how to stay in space. The new program is called Artemis, and it's built very differently than Apollo. It started in 2022 with Artemis 1, an uncrewed mission that flew around the moon and back. No astronauts, no landing, just one question: can the spacecraft survive space? And it did. And next comes Artemis 2. This mission will send astronauts around the moon, the first humans to leave Earth's orbit in over 50 years. No landing yet. This mission's about testing humans in space again. And at the time of making this video, Artemis 2 is set to launch in a couple of weeks. Maybe. Keeps getting delayed. For the mission, the SLS rocket will carry the Orion capsule. And the Orion capsule will carry 4 astronauts who will be traveling through space for 10 days, covering 600,000 miles on a roundabout course that will go around the Earth, by the moon, and back home again. And the Orion capsule that's carrying the 4 astronauts, it's about the size of 2 minivans. That's not a lot of space for that long of a trip. So I thought I'd test out these conditions in my car with my family. We'll see how it goes.
What do you have food in the car for? You can't have food in here.
Smash it into the ground.
It soon became apparent that spending so much time in such a confined space would be a challenge of epic proportions. I don't know how those astronauts are going to do it. Good luck, Reed, Victor, Christina, and Jeremy. And can I say props to NASA for putting the first woman and the first person of color on a mission to the moon? Up until now, it's just been white guys. Now, don't get me wrong. These guys were outstanding, accomplished, and incredibly brave individuals. But it's nice to see that we're finally utilizing the entire human talent pool. And in the near future will come even more Artemis missions with the ultimate goal of landing humans back on the surface of the moon. The plan is to land near the moon's south pole, where scientists believe water ice is hiding. Super important for reasons that will become clear in our next video. And that's the big difference. Apollo proved we could go to the moon. Artemis is about learning how to live and work there, and turning the moon into a training ground for space exploration. Because if we're ever gonna do anything meaningful further than the moon, this is where it starts. And that's what's coming in our next episode. So until then, stay curious. Earth is a terrible place for launching rockets. It has thick air, strong gravity, and it takes huge amounts of fuel just to leave. But there is a much better place, and it's only 3 days away. Today we're talking about why we're going back to the moon, and how it could become humanity's first base in space. We'll look at how the moon is trying to kill you, how the water hiding in darkness will change everything, and why launching from the moon is way easier than launching from Earth. I'll even show you. But now comes the big question. Why go back at all? It's because now we don't want to just visit the moon, we want to have a permanent presence on the surface. You know, a moon base. That means living there for weeks or months, building habitats, generating electricity, recycling air and water. Basically, learning how to survive somewhere that is completely different than Earth. And the moon, it's perfect for that, because it's pretty close, it's easy-ish to resupply, and if something goes wrong, we can make it back to Earth. It's a baby step on our way to explore the universe. But let's be clear, the moon is trying to kill you. It doesn't have an atmosphere, which means there's no air to breathe, there's no air pressure, and there's nothing to stop the radiation of the sun, like our air does here on Earth. The temperatures, they swing wildly. Even though the Earth and the moon are about the same distance from the sun, the day side of the moon, where it's sunny, is 250 degrees Fahrenheit. And then if you go to the night side, where it's dark, it's negative 280 degrees. And that's a swing of over 500 degrees Fahrenheit. 250, negative 280, 250, negative 280. It really makes you appreciate our atmosphere even more. So where would you even build a base on the moon if you could, given that it's so incredibly inhospitable? Well, this is where things get interesting. Near the moon's south pole, there are craters that never see sunlight. They are permanently shadowed, which means they're incredibly cold, and they have been for a long time. And inside those shadows, scientists believe there is water ice. And water changes everything, because water isn't just for drinking. It can be broken apart into hydrogen that we can use for fuel, and oxygen that we can use to breathe. So suddenly, the moon isn't just a place we visit, it becomes a place that can support human life and exploration. And now here's the part that really changes the game, because launching a rocket from Earth is really difficult to do. We've got a lot of gravity, we've got really thick air that wants to tear rockets apart, and we have to carry all of our fuel with us. Now let me show you what I mean. On Earth, most of a rocket is fuel, fully loaded and really heavy. On the moon, you would need just a fraction of that fuel, because the moon's gravity is 1/6 of Earth's, and there's no atmosphere to slow you down, which means less fuel, lighter rockets, and a much easier launch. It's like these two film canisters. I'll share how this is done at the end of the video, and I'll explain what a film canister is for you kids. One I've loaded down with weights to represent a launch from Earth, and the other, It's like a launch from the moon. And when they launch, you can see just how much easier it would be from a moon base. I mean, Earth is like trying to jump out of a pool, and the moon's more like stepping off of a curb. It's a classic case of Newton's second law of motion. Am I right, people? And Newton's second law of motion is stating the obvious in a scientific way. It basically says that if you push the same on two objects, the lighter one will accelerate faster. Or if you push on two identical objects, the bigger force or pusher will accelerate faster, which explains a lot about how rockets launch. And this is the big idea. If you can live on the moon, make fuel on the moon, and launch from the moon, then suddenly going to Mars gets a lot easier. Asteroids become reachable, and deep space becomes possible. Because the moon isn't the destination, now it's a launch pad to the future. A place to learn, to build, and to take the next step into our exploration of the universe. And speaking of the rest of the solar system, what if I were to tell you that the most interesting places in the solar system aren't even the planets? And that's what's in our next episode. So until then, stay curious.
Now, to make a film canister rocket at home, you need eye protection, water, Alka-Seltzer, and a film canister. Simply add Alka-Seltzer to the film canister, and you can experiment with different amounts. Fill up the canister halfway with water, and then snap the top on and place it on a solid surface, top down. Back up and enjoy. The reaction between the tablet and the water creates carbon dioxide gas, the pressure builds, and it launches. And to keep kids busy for longer, have them turn the canister into an actual rocket-looking object, or explore with different amounts of Alka-Seltzer and water. All of these little changes are science in action.
There are 8 planets in our solar system, 5 dwarf planets, and over 400 known moons. Which means most of the worlds out there aren't even planets. And so if you could go anywhere, where would you go? Would it be to find life, to explore, or just to have a good adventure? Because soon, with a moon base, this might not be science fiction anymore. And the biggest problem we'll have is deciding where do we go next. Let me show you one of those worlds. This is Europa. It looks like a frozen ball of ice, but beneath the surface, there's likely a global ocean with more water than all of Earth's oceans combined. And on Earth, where there is water, there is life. 2 years ago, NASA launched the Europa Clipper to orbit the moon and to collect evidence on if it could hold life. One day, we'd like to get through the ice to see what we could find down below, but there is quite a bit of ice. And who can imagine what we might find down there? Or maybe nothing. And Europa is just one of hundreds of moons. But if Europa is exciting, this next one is honestly kind of unbelievable. Here we have Enceladus. It's small, it's icy, it doesn't look like much, but if you look closer, it's blasting giant geysers of water straight into space. Let that sink in. There is a moon shooting water into space. And we didn't just see it, we flew a probe straight through those plumes. And inside them, scientists found organic compounds and water, the ingredients for life. It's not proof of life, but it's everything it needs. That's basically the universe saying, hey, you might want to check here. And then there's Titan. Now, Titan is one of the strangest places that we have ever been. And I say been because we actually landed a probe there back in 2005. It has clouds, rains, rivers, lakes, but it's not water. It's so cold there, you find all these things made out of methane, what we would call natural gas. Titan is like a frozen alien version of Earth, a completely different kind of world that might hold the answers to how life began. And these aren't the only ones. There's Io, which is covered in volcanoes. There are moons with underground oceans, moons with strange chemistry, and moons that we haven't even begun to explore. And here's the crazy part. All of this becomes reachable once we stop launching rockets from Earth and we start launching them from the moon. Because with a base on the moon, we have a place to live, a place to refuel, and a place to launch. And these worlds go from being impossible to possible. Because now we're not just going for cool photos, we're going to answer the biggest questions there are. How did life begin? Is Earth unique, or is life everywhere? And we might not find life on a planet first. It could be on a moon. So Earth's moon helped life become possible here on Earth. But other moons might show us that life isn't rare at all, that it's hiding in places we had never previously thought to look. Beneath ice, inside of oceans, and on worlds we're just beginning to explore. And it all starts with one small step back to the moon. There are 8 planets in our solar system, 5 dwarf planets, and over 400 known moons, which means most of the worlds out there aren't even planets. And so if you could go anywhere, where would you go? Would it be to find life, to explore, or just to have a good adventure? Because soon, with a moon base, this might not be science fiction anymore, and the biggest problem we'll have is deciding where do we go next. Let me show you one of those worlds. This is Europa. It looks like a frozen ball of ice, but beneath the surface, there's likely a global ocean with more water than all of Earth's oceans combined. And on Earth, where there is water, there is life. 2 years ago, NASA launched the Europa Clipper to orbit the moon and to collect evidence on if it could hold life. One day, we'd like to get through the ice to see what we could find down below, but there is quite a bit of ice. And who can imagine what we might find down there? Or maybe nothing. And Europa is just one of hundreds of moons. But if Europa is exciting, this next one is honestly kind of unbelievable. Here we have Enceladus. It's small, it's icy, it doesn't look like much, but if you look closer, it's blasting giant geysers of water straight into space. Let that sink in. There is a moon shooting water into space. And we didn't just see it, we flew a probe straight through those plumes. And inside them, scientists found organic compounds and water, the ingredients for life. It's not proof of life, but it's everything it needs. That's basically the universe saying, hey, you might want to check here. And then there's Titan. Now, Titan is one of the strangest places that we have ever been. And I say been because we actually landed a probe there back in 2005. It has clouds, rains, rivers, lakes, but it's not water. It's so cold there, you find all these things made out of methane, what we would call natural gas. Titan is like a frozen alien version of Earth, a completely different kind of world that might hold the answers to how life began. And these aren't the only ones. There's Io, which is covered in volcanoes. There are moons with underground oceans, moons with strange chemistry, and moons that we haven't even begun to explore. And here's the crazy part. All of this becomes reachable once we stop launching rockets from Earth and we start launching them from the moon. Because with a base on the moon, we have a place to live, a place to refuel, and a place to launch. And these worlds go from being impossible to possible. Because now we're not just going for cool photos, we're going to answer the biggest questions there are. How did life begin? Is Earth unique, or is life everywhere? And we might not find life on a planet first. It could be on a moon. So Earth's moon helped life become possible here on Earth. But other moons might show us that life isn't rare at all. That it's hiding in places we had never previously thought to look. Beneath ice, inside of oceans, and on worlds we're just beginning to explore. And it all starts with one small step back to the moon.